How do you design a hotel booking service? Hey everyone, welcome back to another Exponent System Design mock interview. My name is Kevin Wei. On today's show, we have Neeraj. We're going to be doing a system design, a technical question. This is one that's commonly seen in engineering or engineering manager interviews. And before we get into this, Neeraj, do you want to say a few words to introduce yourself first?
Hey everyone. My name is Neeraj Gupta, and I'm working as senior engineering manager. And I've been being in the software industry for more than 16 years, having taken hundreds of interviews in system design, engineering manager, behavioral coding interviews, and definitely happy to be giving an interview myself today.
Awesome. Thanks for coming on today's show. So today, this is the question I want to ask. How do you design a hotel booking service?
Okay, so hotel booking system or service. So let me think about uh, functional requirements to start with. So we are talking about hotel booking system. So when I talk about it, is it like something like booking.com or like Airbnb or maybe reserving a small hotel or something?
Yeah, if you're familiar with like booking.com, let's use that as an example for what we're trying to build.
Sure. So like booking.com, there can be multiple hotels. So there can be like maybe viewing a hotel page can be required, then adding hotel, maybe an administrator, then deleting, updating, kind of those normal operations from the hotels. Then do we want to search hotels? So maybe that's one of the requirement if you think that search. Then if I have selected a room, there can be multiple people booking the same room at the same time. So one thing is, so are we going to be assigning room numbers upfront? Or I think most of the hotels they assign room numbers at check-in.
Yeah, good question. Good question. Let's, for the sake of this exercise, assume that rooms are assigned during check-in, and we also do not want to double book occupancy. So just keep that in mind.
Sure, sure. Yeah, those are more about non-functional. So requirements. So mainly concurrency, maybe not no double booking. So if we have only one room available, then only one person should get like for a particular room type. I would say uh, the room numbers are going to be assigned later. So searching hotels is one option. Then maybe like when we book a hotel, there will be order created, maybe reservation. That can be one option for requirement, maybe cancellations, payments. So what do you think? I mean, in terms of the functional requirements.
Yeah, this looks good. This looks good.
Okay, sounds good. So then in terms of non-functional requirements, let me see. So, and there are sometimes like hotels, what they do is they do some kind of overbooking where I mean, if like if there are even if the hotel is sold out, they kind of book more rooms so that to prepare in terms of cancellations in future. Do we want to support that feature or are we good without it?
I'll leave it up to you. So maybe like initially we can leave it out, but if you want to talk about it too, I'm kind of curious how you would approach that.
That's fine. So, like, okay, so concurrency we discussed. I'm pretty sure scalability to the extent of booking.com, it's going to be highly scalable system. And I think from latency perspective, I guess viewing hotel in general, we make sure it is fast. And I mean, even if it is like 150 milliseconds or such kind of view and even search, I think search should be fast in general. So I guess that is could be one non-functional requirements. And from security perspective, yeah, we want to make sure that people have like logged in. They have their, I mean, the identity access management system is properly built. So even DDoS protection, rate limiter. So those are standard things. I think I would just assume that those kind of non-functional requirements would be good to get started. Do you
Yeah,
think it is?
that sounds good. That sounds good. Yeah, I think this would be a good start for us to make sure there's a good user experience so that they're not, users don't get frustrated and don't drop off in the experience. And also from a performance and security perspective, right? So, yeah, these non-function requirements sound good.
Sure, sure. So in terms of back of the envelope estimation, so there can be, I mean, let's assume there are probably 1 million maybe hotels, and each having some kind of 100 rooms. So maybe 10 room types. I'm just uh, throwing some numbers, what looks like the decent estimation. So maybe 10 room types, they can be king bed, they can be like suite, or on an average, maybe 10 room types or 5 room types, I can assume. So that comes out to be total of like 1 million hotels. So around 100 million rooms. So 100 million rooms are, if we talk about room types, so 100 million rooms, if we talk about 5 million room types, and if we are reserving like per day, right? So per day, if we are reserving for maybe 10 years, so that's going to be a lot of data to store. So every day, let me come up with a data model also, and that will help define how much storage it will need. But uh, yeah, it seems like it's going to be pretty good number in terms of, like, let's say if we are talking about reservations.
Okay. Yeah, and let's just do like a quick estimation here. We don't need to get too deep here.
Yeah, 1 million hotels, 100 rooms, so 100 million per day into 365 multiplied by 5 equal to around 180 billion rooms. Um, yeah, so 180 billion rooms, and that's going to be a lot of storage if we are storing every room reserved. So even if it is taking 100 bytes per reservation, so it's going to be probably 18 terabyte, which is going to be huge. So we need reservation. We need some, like, we can't store it on one server for sure. So the other thing I think here, since we don't want double booking, I think we would need some kind of inventory storage or so, where we will have uh, where we'll have like how many rooms are available, how many rooms are kind of reserved. So that kind of data storage in terms of table, we can have, and we can surround it with uh, different transactional features or other concurrency control mechanisms to make sure we are not double booking. So here, I think, here also, let me first go over some data model, and maybe I'll come up with those numbers.
Sure, yeah, I think that'd be helpful.
Yeah. So, but the other thing is, I think these hotels will have a lot of images, I think. So, because you need, when you are viewing a king bed, you might want to scroll through the images, you might want to scroll through the images of the hotels. So, there will be plenty of images. I think that can be stored in maybe S3. I'll come over in the data model. And I think we'll need CDN coverage also, that I'll come up with the design. So even if it is 10 images, I mean, it's going to be huge storage even there. So I think it cannot be stored in relational at all. So let's see. I mean, if we talk about these system, let me see here. So we can have probably some databases or services also I'll come up with. So maybe, I mean, uh, let me see. So if we talk about one hotel, so one hotel can have hotel ID, then it can have like its address, phone. I mean, those standard things that can be stored in a hotel. Let's see if I can reduce down the font for this one. So, and zip, and other things, latitude, longitude, we can store all of these things. Then if we talk about a hotel room, so there can be hotel rooms. So I think so. Mostly it will be like room type. So hotel ID, then room type. I would go with the inventory first. Let's see inventory. So inventory storage. So for each room type, for a given date, how many uh, how many are the available rooms for the given room type? So available count and how many are the room total room count for that particular day for the given room type. So I think this will be helpful for viewing the inventory of a given hotel for a given date when we select dates and multiple dates also when we select.
Mm-hmm.
So that we can do in the inventory part. And then let's see, then people can make reservations. So maybe some orders or reservation table we can have when they are making reservation. I mean, for a given hotel, which date I will need a start date, end date, and which rooms are being booked. So room type kind of ID. I would say ID here, room type ID. So we can have more tables for room type room type ID to room type information and all those things. But mainly for that particular room type ID, how many rooms are being booked.
Got it. This makes sense. Like I trust that you can do the same thing for a few other like hotels and other data models. I'm more curious now. How would you design the system for this? I think everything up until here makes sense. Just for the sake of time, I wanted to speed through some of this.
Sure, sure. So system wise, let's see, and I'll come up with some APIs also. Then, so here, I think I'll have some services. Okay, one is inventory service that is talking to that is talking to, um, we can build cache also, but let me first have database here. So like inventory service talking to this data storage. So what I would do is if we have a user, so let's say user. So the user, usually what I do is, I mean, for every page, I try to make sure like I build in a format where it's like backend for front end format, where if we have native, like if we have iOS, Android, mobile web, desktop web, or even if there is any other UI platform, they can share the same kind of backend. So because the UI is a lot similar, so that's why it reduced duplication. So I usually have some kind of backend for front end experience or experience layer that's mainly services. And for this one, I mean, for any of the servers that I'm going to have, I'll be having load balancer on top of it. So like if you are talking about a View Hotel service, so for View Hotel, there is going to be a hotel page that will be powered through such kind of experience layer. Then we can have another something similar. We can have like let's see here. So if we are talking about viewing the hotel, so for that, if somebody is trying to get about the inventory for that hotel, so they will call the inventory service also. So that will get the database, but there can be situations where, I mean, let's say if they make a payment. So if we are talking about kind of reservation experience, reservation, so then it will be talking to the reservation service as well. And it needs to talk to, I mean, when you do reservation, it will need to talk to the inventory also to make sure we are having, I mean, we are having the right number of rooms reserved so that both are in sync with each other. Let me go over that in a little bit.
Sure.
So we'll have kind of reservation database. So there can be a couple of approaches. We can do some kind of microservice based architecture where reservation service has dedicated database, and they can be part of like the same database also. What it will help is, I mean, if we are doing transactions and all, then then having them on the same server would make life easier. But practically, if we think about bigger companies, you usually have different teams that are managing the viewing the part, like different teams that are managing viewing part or reservation part, and there are plenty of complexities behind the scenes. So a lot of the companies prefer having separate databases and separate storages. That increases some complexity, but let me go with that in a bit. So in case, let's say, if somebody is making payments and the payment fails, so I'll have in reservation, I'll have a status also. So where status can be probably, I would say, maybe pending. If we want to support some kind of timeout, I'll come over to that. Pending, then complete maybe can be a state, then maybe cancel can be a state. Or so if, let's say, a reservation is canceled or so, then we want to make sure the inventory is reverted also, like available count, the ones that were reserved before, that available count needs to increase because a reservation is canceled. So for that, I mean, whenever we make payment, a lot of the times the payment processor, they reach out to us in an offline way through some kind of events processing, so or callbacks. So what I would do is maybe I'll create some kind of queuing mechanism as well. So where I'll have some kind of queue, event queue, that and I'll create a consumer also. So whenever, so this consumer will consume from those offline event queues, and offline event queues will listen to some kind of events. Let's say payment failed, so it will listen to, I would say, it's a payment failed, some kind of topics. If we talk about Kafka or RabbitMQ, those kind of those queues do support listening to such kind of topics and events. So payment failure, or if it's probably, I mean, reservation canceled. So in all those use cases, I'm going to be, as soon as those events happen, I'm going to be listening to, I'm going to consume it, then I'm going to make the service calls, appropriate service calls to, for reservation service, to make sure that it is canceled or the state is updated. And I'm going to make call to inventory service also to update the inventory. So I can go a little bit into inventory service, but let me first check this.
Yeah, and maybe we can kind of just walk through at a high level. I think everything makes sense so far. Maybe walk through at a high level, just from the user to booking a hotel, like how all these services are working together. Just maybe in like a minute.
Yeah. So when a user books a hotel, they get the UI screen, experience layer, and they will be doing the orchestration through different services. So when the user books the hotel, it will call reservation service, and it will also call inventory service. To inventory service, what it will do is, let me go with that one first.
Okay.
So the way, I mean, since I mentioned about inventory table here and reservation, so the way it will do it is like, maybe, I mean, such kind of queries like selecting. First, I'll get the available count. I want, let's say, if there is only one room available, so I'll first get the available count from this inventory table. And let's say if I get this available count from the inventory table, where if I have selected date between some start date and end date, uh, user provided, let's say if I want to pick from today to 3 days from now. So in these, I'll get the available count, and I'll check if that available count is greater than what I'm requested count. So, or maybe less than requested count. In that case, I can't book. the hotel, because the rooms, that room is not available. So for this one, date, hotel ID, I'll have equal to some hotel ID, and room type for a given room type. So if the available count is less than the requested count, then I can't book the room. In that case, and here in that case, I would like to fail this. But in here, I mean, I get the available count and then I update this inventory table, kind of. So update this inventory table. So set, available count equal to available count minus the requested count. So where all these things, okay. So what I see is like if two users are trying to book a last room, so I can see some race conditions. Sorry, I'm going off track, but I think this is an important one in this particular design. So because we want to make sure it is not double booked.
Right.
So if I'm going with a relational database, so and I'm checking the inventory for the user here, like two users are trying to book the same room. So for both of the users, the available count will be 1 and requested count will be 1 as well. So if available count is less than the requested count, right now, I mean, both of them will see available count is equal to requested count. So they will proceed here and they will both update the inventory and reduce the available count. So one of them can make the available count as negative. So this race condition, I think there are multiple ways that we can protect it. I mean, we can protect it by adding a transaction on top of it. So we can do begin transaction and end here. But when we do this, there are multiple transaction isolation methods like read committed, read uncommitted, and repeatable read and serializable. So if we do anything other than serializable, then we will still run into the same issues. It's not so. What serializable helps is these transactions for one user, it will make sure that all these statements are executed once, and the other user is waiting, cannot proceed. I mean, because only one transaction can proceed in that serializable isolation level. So in that transaction, only one transaction will proceed. So for user 1, it will proceed and inventory will be updated correctly. But for user 2, the available count would be 0. So user 2 would be fine. In this case, the problem that I see over here is, given that it is serializable, we are blocking the transaction, we are blocking the code for a long time. And that can be inefficient, potential of creating deadlocks, potential of having users wait for a long time to get the room available. So it's not that, I mean, it is good. I mean, it will solve the concurrency issue, but it's not going to be that efficient. So yeah, so there are other ways. I mean, we can do select for update here. It will lock the rows. We don't need the transaction to be serializable there. It will lock the rows. It's still pessimistic locking. There is other way where we can have a version in these tables. So it's like optimistic concurrency control that is helpful if there is not a lot of contention. So, and I think I'm just going a little bit faster, but I think please interrupt if there are any questions. But there is another thing that I can think of is having database constraints, though it's not supported by all kinds of databases. But there's database constraints also, where I can create a constraint.
And actually, before like getting too deep into this, I appreciate you walking through how you would optimize this race condition or how you would solve for it. I think this here makes sense. For the sake of time, and I think your overall system design makes sense here, I would love to discuss some other optimizations you would make. So, race condition aside, are there any other optimizations that you think could be made in your design?
So one thing is inventory. I mean, yes, from the speed perspective, like we mentioned, it should be 150 milliseconds, which is pretty high, which is pretty like I would say strict in terms of the SLA. So we can create some kind of cache here for inventory service where, although I think ultimately the booking part, when you are ready to book, ultimately it will go to the database and validates all these through constraints and make sure there is no double booking. But when a user is seeing, they can see some kind of uh, that inventory service can talk to some kind of cache. Let me see if there's no cache, but yes, I think we can have a block for cache that inventory service talk to. Before talking to the database. So that cache can be built in multiple ways. I mean, that cache can store the available count for a given room type. A lot of the times, I mean, since people book well in advance, maybe 1 month in advance, and all those things, so we wouldn't get into the conflicts later on when it comes to the database. But yeah, so we can store the available count for a given room type in those cache, and whenever it is booked, either we can update the cache offline to improve the booking performance. We can remove the value, like delete from the cache also, so that next time when you're reading from the database. So if you delete the cache value, I mean, it will be slower next time. So I would prefer that when we do a booking, it goes through the same event queue mechanism, like some kind of event that happens, and that consumer will update the cache for
Okay.
the user. So that's one option, one optimization. Then
Got it.
I was
Uh,
mentioning about images. Yeah.
yeah, and I think that's great. Now, for the sake of time, instead of diving into the same level of details for other optimizations, can you just speak high level of like what are some other optimizations you might make if you had more time to work on the system design?
Yeah, I mean, one thing is images. I think I mentioned before. So images will be stored in the S3, and that can be retrieved through CDN, that is geographically located, and um, because images take a lot of space and bandwidth as well. So that's one option. Then other things, I mean, not optimizations, but there can be some like concurrency issues with when if I talked about just inventory service, but if we talk about updating inventory as well as reservation, like those two tables at the same time, because what we want to make sure is as soon as you reserve a room, that reservation entry should be there and inventory should be updated. Both of them should be at the same time. So that one, if we are going with the microservice kind of architecture, I mean, there are multiple ways, like two-phase commit is one option. And there is something called Saga also. So that helps in concurrency control and making sure that those two tables are in sync. So that will be helpful. And even, I mean, if you're double booking, I think there are ways to optimize, ways to control the, I mean, make sure that people are not, there are no two entries that are added to reservation table also for the same reservation, but by smartly creating the IDs. Let me think about any other way to optimize this.
I think that's fine for this exercise, Niraj, and I think we're at time now. So thank you for walking through how you would design this hotel booking service. We talked about functional and non-functional requirements. You gave us an estimation. We walked through like a high-level design. We went deeper there. We talked about optimizing for solving for the race condition and optimizing for a few other things. Um, Now, And I think for the purposes of an exercise or an interview, this is the kind of details that we would get into. Now, before we close out the video, given your years of experience doing system design, do you have any tips for the audience if they were to face the same kind of question around booking a hotel system?
Yeah, I think most of the system design questions, one thing to remember is mainly we should follow the right format. It's system design is just a kind of snapshot of what you will encounter in the real life. So in real life, if we have product requirements and we want to make sure that we are building a system that is tying to those product that is adhering to those product requirements. So that's why we come up with functional requirements, non-functional requirements, and whatever system we are designing, it's based on estimation. If something doesn't fit on the server, then only we do. I mean, we can do sharding also here because that I couldn't get to, but there are multiple ways. But we have to make sure that we are solving for the problem in hand. So that's why a lot of these steps are important. High level is important. Optimizations are important, and considering all those kind of use cases are important. So definitely, I think following the format uh, and thinking through all the steps is definitely I would recommend.
For sure. Great advice. Thanks, Niraj. And for the audience who are watching at home, good luck. I hope you found this helpful. Again, these are typically asked in engineering or engineering manager, typically in on-sites or even in first round interviews. So hopefully this is helpful, and good luck in your upcoming system design interview.